This homework solutions video is for Science and Mechanics, Unit 1, Math Review and Motion, Section 4, Acceleration. Number 1, a car slows down with a deceleration of 3.1 meters per second squared. How much time is required to slow from 26 meters per second to 3 meters per second? So with this problem, the first thing that we need to take a look at is our formula wheel for change in speed, time, and acceleration. So in this problem, we are trying to solve for time. So again, we cover up time, we're left with change in speed divided by acceleration. So time is equal to our change in speed divided by the acceleration. And the change in speed is found by taking the final speed minus the initial speed. So now we can start to substitute some numbers into our formula. So our final speed is 3 meters per second. Our initial speed was 26 meters per second. The acceleration, we're told, is a deceleration of 3.1 meters per second squared. So a deceleration is actually a negative acceleration. So our acceleration is a negative 3.1 meters per second squared. So when we take 3 minus 26, we end up with a negative 23 meters per second on top. And on the bottom, we have a negative number as well. So those two negative numbers will cancel each other out. That will become a positive number. So when we divide this in our calculators, we end up with time of about 7.42 seconds. Number 2, a truck can accelerate from 0 to 60 miles per hour in 9.5 seconds. Find the acceleration in feet per second squared. So in this problem, the first thing that should jump out to us is that our speed is given to us in miles per hour, but acceleration is in feet per second squared. So we have to convert our speed in miles per hour into feet per second before we can do any other calculations. So we have 60 miles per hour, write that as a fraction over 1. From our conversion table, we know that 1 mile per hour is equal to 1.47 feet per second, approximately. So mile per hour over miles per hour cancels each other out. 60 times 1.47 is about 88.2 feet per second. So now we can use that 88.2 feet per second as our speed. So again, we're going to look at our formula wheel for change in speed, acceleration, and time. So now we're trying to find acceleration. So acceleration is equal to our change in speed divided by time. So again, change in speed is final speed minus initial speed. So in this problem, our final speed is the 88.2 feet per second. The initial speed is 0, so we can leave that off. When we divide that by time of 9.5 seconds, we should get an acceleration with units of feet per second squared. So when we divide this in our calculators, we get approximately 9.3 feet per second squared as our acceleration. The next part of this problem asks us to find the average speed during these 9.5 seconds. So average speed is equal to our initial speed plus the final speed divided by 2. Our initial speed from before is 0. Our final speed we found was 88.2 feet per second. And then we can divide that by 2 to get an average speed of 44.1 feet per second. The last part of this question wants us to find the distance traveled during these 9.5 seconds. So distance is going to equal our average speed times the time. So our average speed we found in the previous part to be 44.1 feet per second. Time, we're told, is 9.5 seconds. So when we multiply 44.1 feet per second times 9.5 seconds, we get approximately 419 feet.